And this is your last lesson for Chapter 5, Quadratic Equations. We are talking about the fourth method of solving algebraically, which is the quadratic formula. Again, remember when we're solving, we're talking about the values or value of x that work when the equation is equal to 0. So we are finding, remember we call these x-intercepts. Solving means you're looking for where does the graph cross the x-axis, but we're doing it algebraically. At the end of the lesson, we'll tie that back to graphically, and the circle will be complete. So first of all, the quadratic formula. You must know this. You must have this memorized. I'm sure many of you already do. I'm sure you have it even to the tune of Pop Goes the Weasel. It goes something like this. X equals opposite b plus or minus square root b squared minus 4ac all over 2a. Yes, you're welcome. Congratulations. So that's the quadratic formula. A, B's, and C's, again, those are coming from a standard format when you have ax squared plus bx plus c. So it is super important for us on this lesson that you have your equation equal to 0. If you have your bx's and your c's on the other side of that equal sign, this formula will do its work correctly. It is super important that you have your A, B's, and C's on the same side of the equation. If they are on opposite sides, the formula will do its work correctly, but it will not give you the correct answers because we did not set up the problem correctly. So make sure it's equal to 0 first. Always, always, always. And in our first example, we see that right away. Must set equal to 0. First of all, do that. So move this 4 over. So we get 3x squared minus x minus 4 equals 0. Then we go ahead and we pull out the a, b, and c values. A will be 3, b is -1, and c is -4. Then we come to our formula and we plug in the pieces. So x equals opposite b plus or minus square root b squared minus 4ac all over 2a. Now, we have to be careful with some of our negative signs here. So we will get x equals negative is +1 plus or minus. This becomes 1, +1, because the parentheses are squaring it. -4 times +3 is -12. -12 times -4 is +48. And then that's all over 6. X equals 1 plus or minus the square root of 49, all over 6. So we end up getting x equals +1 plus or minus 7, all over 6. And again, this is two answers. X equals 1 plus 7 over 6, which is 8 over 6, or 4 over 3. And then we have x equals 1 minus 7 over 6, which is -6 over 6, which is -1. So x equals 4/3, and x equals -1. If we take these two values and plug them back into our original equation, they will give us 0. All right, the next couple examples we're going to look at, they're going to be the same idea, but they're all going to have something a little different for us to watch out on. This one's already set up for us, which is super nice. So our A is 1, our B is 6, and our C is -5. Let's go ahead and start with that. X equals opposite B plus or minus square root B squared minus 4AC all over 2A. -5 for C and A. So when we simplify, -6 plus or minus 6 squared is 36. -4 times 1 is -4. -4 times -5 is +20 all over 2. So x equals -6 plus or minus square root 56 all over 2. We are noticing what is a little different here. Notice that for this one, the 56 is not a perfect square number. So when we try to simplify this one here, we will get x equals negative 6 plus or minus, try to break up the 56. Let's see, 56 could be divisible by 4. It could be 4 times 14, and then that's all over 2. This means that we can have negative 6 plus or minus 2 root 14 all over 2. Now, we can simplify, yes, but you need to make sure that you're not only simplifying from the first term, but also the last term and the bottom term. All three of those. So many people will do only the negative 6 and the bottom 2. It must be all three pieces that it's coming out of. So we end up getting negative 3 plus or minus root 14. Notice I did not cancel a 2 from underneath the square root. You are not allowed to cancel under a square root when there's a number outside of a square root. That doesn't work. But because these are connected by multiplication, I can cancel the 2 in front. And then this is all over 1. So that's just the number. Again, this is two answers. This is negative 3 plus root 14, and this is x equals negative 3 minus root 14. Those are the two answers that we get. Another thing that we'll have to look out for, first of all, let's get him set up correctly. Let's move everything over. It does not matter which side we move everything to. Let's just go ahead and move this left-hand piece, since that would be quicker and easier. So we get 0 equals negative x squared plus 2x minus 5. So we have an a value of negative 1. We have a b value of 2 and a c value of negative 5. So we end up getting x equals opposite of b, so negative 2, plus or minus square root b squared minus 4ac all over 2a. Negative 2 plus or minus the square root of 4. Negative 4 times negative 1 is positive 4. Positive 4 times negative 5 is negative 20 all over negative 2. And here is where it gets a little weird. Notice that now we have the square root of negative 16 all over negative 2. Remember, I promised you that imaginary numbers would be coming back. Here they are. Now we have x equals negative 2 plus or minus 4i all over negative 2. And again, if we're going to simplify this, you want to make sure you cancel the first term, the last term, and the bottom term. So we get x equals negative 2 divided by negative 2 is 1. The plus or minus sign is not going to change, because if you divide a plus by a negative, you'll get the negative. But if you divide the negative by the negative, you get the plus. So it stays the same. 4 divided by 2 is 2i. And again, that's two answers. 1 plus 2i and 1 minus 2i. So you can have i's come out of your quadratic formula when there is that negative underneath. So don't forget the i's. They show up. All right. And another example for us here. Let's go ahead and move the negative 2x squared over. Get him out of the way. So we end up getting 0 equals negative 2x squared plus 7x minus 8. So x squared equals, whoops, sorry, not x squared. X equals opposite b plus or minus square root b squared minus 4ac all over 2a. So we get x equals negative 7 plus or minus 49. Negative times a negative is positive 8. Positive 8 times negative 8 is negative 64 all over negative 4. Looks like we're going to have another imaginary number come out. 49 minus 64 is negative 15 all over negative 4. X equals negative 7 plus or minus I, that's the negative, and then root 15 doesn't break up into anything, so it just stays there, and then we have our negative 4. So that negative gave us another I in our answer. Again, this is really equal to two answers. This is really equal to x equals negative 7 plus I root 15 over negative 4, and x equals negative 7 minus I root 15 over negative 4. Those are the two. So not only do we have i's, but we also still had square roots left in our answer, and that's okay as well. So we said we'd take this back to graphing. To finish up our notes then, we want to notice some patterns that happen in our quadratic formula when the number under the square root is positive. So let's say, for example, you've been solving, and you get to the point where you have x equals 5 plus or minus the square root of 9 all over 2. And so we say, okay, x equals 5 plus or minus 3 all over 2. This means 5 plus 3 over 2, which is 8 over 2, so x equals 4. And then we say, okay, x also equals 5 minus 3 over 2, which is just 2 over 2, which is 1. Meaning those two answers are where we graph 1, 2, 3, 4, and 1. And then we'd have to check our original equation, whatever that was, to see if the parabola is heading upwards through these or if it's heading downwards. But we know that the parabola is crossing through those 2 points because those are our x values. Now, if we have a negative number underneath, so let's say you've been solving, and you get x equals 5 plus or minus negative 9 over 2, you end up getting 5 plus or minus 3i all over 2. And then we go, wait a second, i's? I don't know how to graph i's. And so we actually say that it's not crossing anywhere on this line. Nothing is touching here. The parabola might be upwards above your line, or it might be downwards beneath your line, but nowhere is it crossing. So negative numbers underneath here mean that there's actually no real solution. And we say that makes sense because this is imaginary. So we give the imaginary answer, but we don't graph it. And then the last option is, instead of having a positive or a negative number underneath, let's go ahead and say, this is a typo here, sorry ladies and gentlemen, let's go ahead and say that you get a 0 under your square root. So you've been solving, and you get x equals 5 plus or minus, and you're like, oh, wait a second, 0 over 2. And you go, oh, well, x equals then 5 over 2 because there's no square root of 0. And you realize, wait a second, I only have one answer. This is where my parabola is. That happens. If you have a 0, that means you only have this first b value over the 2a, and your parabola then will either be heading upwards from this point, touching at just one spot, so that means it's also the vertex point. Or perhaps your parabola is heading downwards from this point, but the vertex is actually sitting on the x-axis. So the options are your square root is 0, in which case it only crosses once. Underneath the square root is a negative number, so you get imaginary numbers and it doesn't cross at all. Or you have a positive number underneath your square root, and the positive number will either cross going downwards like this or maybe cross going upwards like this, but you get 2 crossing points. Congratulations, that is the end of your quadratics unit.